Hello, I am Taylor Brown, and this is Lab 7, and I'm currently on exercise 1, where we have this configuration right here with an op-amp. So we're supplying 10 volts to the VCC, and then a varying voltage to our non-inverting terminal, and 5 volts to our inverting terminal, and then we're grounding this part, and we're measuring the V out as we change our V in. So I have our op-amp right here, and we'll just be using this first op-amp right here. So this right here is my V out, which I'm measuring with this multimeter. The second pin is the inverting terminal, which is connected to the fixed 5 volts on this DC power supply. The third terminal is connected to our non-inverting voltage, which in this case is our varying Vin, so right now I have it set to 0. And then the fourth terminal is where it gets its power, that's fixed at 10 volts. I have it connected to 10 volts. And then I have the op-amp grounded right here. So for the first part, we'll be looking at when the Vin, when this Vin to the non-inverting terminal is less than the inverting terminal. So first we're going to be testing it at 0, and I'm getting a V out of 0, which is what we expected. Alright, so far I have looked at the V out when the Vin is 0 through 4 volts, and for all those values it is 0, which is what we expected. We expect that this will turn on at about 5 volts. So now we're going to be finding our threshold voltage. Right now I'm at a Vin of 4.9 volts, and I'm getting a V out of 0. But when I change it to 5 volts, now my V out is 8.85 volts. So we know that our threshold voltage is somewhere between 4.9 and 5 volts. Alright, so now I have gone through all of our test Vin voltages.
You're basically reading it.
And these are the values that I got. I got it turning on between 4.9 and 5 volts. So starting at 5 volts, I got a V out of 8.85. And now I've gone all the way to a Vin of 10 volts. And I'm still at a V out of 8.85. So the voltage has stayed the same for when the non-inverting terminal is greater than the inverting terminal. Alright, now we're looking at exercise 2 for Lab 7. And for this, we have an inverting amplifier. I've constructed mine right here, and I'm supplying technically 24 volts across this amplifier for its power. So that's basically the same as a positive 12 volt and a negative 12 volt being inputted into it. So I'm using that. And then I have all my grounds at a common node. A problem that I found earlier was that I was using the ground rail instead of putting them all on the same node. And also I thought that the safety ground was the same as like the ground of a channel, and it's not. So after fixing that, I have my graph here. I'll make this go away in a second. But in order to find the gain, I just look at the max value of the output, which is 4.04 volts, and divide it by the min value of the input, which is negative 1.84 volts. This is because when I look at the same point, it is basically the max of the output and then the min of the input. So if I make this go away, yeah, so like for example, I could measure right here at the same point. So it'd be the max of the output over the min of the input. And when I do that, I got a gain value of negative 2.196, and my simulated gain was negative 2.2, so pretty close to what I simulated.